All right, molecular compounds. In the last set of notes we talked about, and we've done a couple of homework assignments on ionic compounds, and I still have them behind me from there. And that is, remember, ionic compounds, we're talking about something that has a positive charge and a negative charge. And then we crisscross those two charges in order to get our formula. All right. Well, this type of molecule we're going to talk about today does not do that. It doesn't do the crisscross method. It does not use the positive and negative charges. Instead, for molecular compounds, which that's the notes we're taking today, is molecular compounds. What these guys use is they are not ions. They're not positive or negative. What they are is they are two nonmetals. So it's going to be two elements from this corner of the periodic table. All right, we're not going to bring in a metal from this side. If I had a metal and a nonmetal, then I have an ionic compound, which was what we learned in the last couple days. Molecular are just these ones up here. Now the cool part about this, again, is I really think you've already heard about this. You just didn't know that you already have. And what I want to show you is, if I gave you that thing, what is that? Well, I hope that right now you just said to yourself, well, that's carbon dioxide. It's the stuff you breathe out. So I'm going to write this down. This is carbon dioxide. All right, so now if you look at that name, well, carbon, that's the first element. There's only one of him, so we just call it carbon. And then we got the second one, it's oxygen. What we learned in the ionic one, we don't call that second one oxygen, we call it oxide. So I'm calling this oxide. Right, and then calling that oxide, notice that I put a di in front of that. I'm noticing it looks like I got a little bright spot in here. I'm going to write it down a little lower so you can see it. Carbon dioxide. There we go, now I think we can see it. So it's oxide because it's oxygen, but then notice there's this little prefix in front called di. Well, what does di mean? Two. Two means di. All right, hold on. I'm going to turn on my light again. So carbon dioxide, that di that's in front of that means that there are two of them. Okay. Now there is a substance that comes out of the tailpipe of your car that's poisonous, and that's this guy. All right, and that happens to be carbon monoxide. So again, notice it's carbon again. So we're starting with a carbon out front. There's only one of them. And then notice how many oxygens there are in this substance. There's only one one oxygen. So again, it's oxide, but instead of saying di, like we did here for the two, because there's only one, we say mono, because there's only one of them. Right? So basically what we have to do on these molecular compounds is we have to put a prefix in front of the name to tell us how many there are of that element. The only time I don't put a prefix is if the first one is 1. The way in which I try and get people to remember that is, I hope we all know that this is carbon dioxide, the stuff I breathe out. It is not monocarbon dioxide. If somebody called it that, it'd be like, what are you talking about, monocarbon dioxide? That's not what I breathe out. I breathe out carbon dioxide. Right? So the first one is 1. We don't put the mono in front. The only time we use mono is for the second guy. Right? But if we have 2, 3, 4, 5, 6, 7, 8, we're going to have to use some prefixes. Where do these prefixes come from? On the Canvas page, there is a list of the prefixes, right? And it happens to be these guys right here. I typed them out instead of having them written in, but you got 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 hexa, 7 hepta, 8 is octa, 9 is nona, and 10 is deca. Right? And those are all prefixes for those numbers. So let's try the next one. I have it on in your notes. Make sure how we got that. We had N2O3. N2O3. So in this one, well, the first guy is nitrogen, but there's 2 of him. So we got to say di-nitrogen. Then there's 3 oxygens, so it's tri and oxide. I always like to think these ones are nice and easy because it's really pretty straightforward. Everything that's in that name tells you everything about this formula. Because it's di, that's 2, and it's the element nitrogen. Then tri means there's 3, and oxide means it's oxygen. Okay. Let's try the next one. We got C8O10. So the 8 is octa. Octacarbon is the first element. And then we got 10, that's deca. And it's oxide again. So it's decoxide. Okay. All right. So in these ones, again, you can use that table, the mono, di, tri. That's the way I always try and refer to it. Mono 1, di 2, tri 3, and so on. You can always use that. So if I were you, I would print that one off now too and add that to a spot where your periodic table is, your polyatomic ion chart is, and now you have this mono, di, tri chart also. So you have 3 charts that you can use to reference. And I also want to point out that's a piece of what chemistry really is. Chemistry is not about memorizing all sorts of charts and graphs and all this kind of stuff. No, the reality is that I want you to learn that there is all sorts of different things, different charts and graphs that have information that other people have already made, and you can go find it. And right now I've already given you 3, the periodic table, polyatomic ions, and the mono, di, tri chart. There's actually, let me grab a book over here and I'll show you. There's books of this, and notice this happens to be the Handbook of Chemistry and Physics. So this happens to have all sorts of tables inside of it of information that's already been found. All right, and you can look inside here and notice that there are like all sorts of tables and charts that give all sorts of information. And this is a humongous book. All right, but you can go in here and you can find out all sorts of stuff about atoms and molecules. We can also find out about why things move the way they do. And it gives me equations, it gives me charts, it gives me things that I can reference, because that's a reference book for all this stuff. And that's something else I want you to be aware of in chemistry is that you can go out and reference this stuff. I don't expect you to memorize it, I expect you to know how to go reference it, that's all. All right, so that's the concept of molecular compounds. There is one more video that I want you to watch that goes along with this. That's kind of important for you to do. So watch the second video, part number 2.